So in this video I want to introduce you to two new derivatives, the derivatives of the sine function and the cosine function. Coming up soon we'll be getting all kinds of other neat things that we can do, but at the moment one of the big things that we need are the derivatives of sine and cosine. So here we go. These are things you want to memorize. The rest of this chapter is going to have a lot more things to memorize and get stuck in your head, so get these in there now. First, the derivative of sine x is cosine x, and the second, the derivative of cosine x is negative sine x. So this is where I would normally repeat these things lots of times. I would say, hey everybody, remember the derivative of sine x is cosine x, and the derivative of sine x is cosine x. Don't forget that the derivative of sine x is cosine x, because you need to memorize that the derivative of sine x equals cosine x. I could do the same thing for this one, but I don't really want to waste your time. The reality is, get these things memorized. There are lots more to come, and if you don't start that now, we're going to be in trouble soon. The derivative of sine is cosine. The derivative of cosine is negative sine. I put that negative there in red in hopes that you would notice it and remember it and not forget that the derivative of cosine is negative sine. Okay, so get these memorized. All of our other rules for derivatives still apply. So in this example, we're going to sort of see that, right? This question is asking us to find the derivative of g of x equals 7x squared minus 4 sine x. So I hope you guys remember that sort of one of our rules for derivatives is that if you've got two things that are added or subtracted to one another, we can just handle these two things individually, right? Now the first part of this, 7x squared, we can just use our power rule on that, right? So, if I have the g of x equals 7x squared minus 4 sine x, again, I can use my properties of derivatives, my rules, to say, alright, well this first thing, I'm just going to bring the 2 down and multiply it with a 7. That'll make 14x, and then I'll subtract 1 from the power, so that second power will drop down to a first power, which isn't even really necessary, but that's okay. Then for the second part of this thing, for this negative 4 sine x part, I can just take the derivative, and to do that I'm going to sort of ignore the negative 4 for a minute, so I'll write minus 4. Then times, by the way, I can do that because that's a constant, remember our constant multiple rule, times the derivative of sine x. Well, we just learned the derivative of sine x is cosine x, and so we effectively have it. We can write that g prime of x is 14x minus 4 cosine x. And that's it, that's our derivative. Keep in mind, everything else we've learned about the derivative is still totally valid, right? What's the purpose of this function? What does it do? Well, if I were to plug an x value in here, it would give me the slope of the tangent to this curve, right? Could I ask you to find the equation of a tangent line? Absolutely. Anything we've done with derivatives so far applies to this, okay? Another example for us, find the derivative of g of x equals 6 times the square root of x minus 3 cosine x. Pause the video, walk through this, do this derivative, and bring yourself back to check. So to take this derivative, I'm actually not going to write g prime of x. I'm going to just write g of x because I'm not ready to take the derivative yet. Many of you may really want to write this as 6x to the 1/2 before you go on. And I cannot emphasize enough, please don't, like sometimes people will rewrite this part and then take the derivative of this and then go back and do the derivative of the next part in the next line. Don't do that. If you're not ready to take the derivative yet, leave the entire line the original function, then go back and make it g prime of x. Then go back and do your 6, bring down the 1/2 x to the negative 1/2 minus 3 times. Now the derivative of cosine, we just learned that that's negative sine x, right? And now it's just a matter of going back and sort of prettying this up a little bit. I could multiply the 6 and the 1/2 together to give me 3. I can move that square root to the bottom, so I have 3 over root x. Now this will be plus 3 sine x, because these two negatives will, a negative times a negative will always give us a positive. And here it is. This is our derivative. Working with derivatives of trig functions is really not hard if you memorize what they are. Today is sine and cosine. Coming up soon, we're going to get some of the other ones. Okay? Now I have an interesting example for you here. The question is, why can we currently, like with our current tools, why can I currently not take the derivative of f of x equals x squared times sine x? Like, why can I not do that derivative? And I hope you've taken a minute to do this. If you haven't, pause the video and think about that. Why can you not do this? Because I would suspect that some people would say, oh, I can do the derivative. The x squared part is 2x. Cool. And the sine x part, that's cosine x. Yay, look, I did it. F prime of x. Woohoo! Unfortunately, this is, super ridiculously not true. I'm trying to make that not equals, right? Not true at all. We don't have what's called a product rule. we don't have something that lets us take the derivative of two functions multiplied together. If this had been x squared plus sine x, we can totally do that. But x squared times sine x, we can't do. So anytime you see two things multiplied together, you either run and hide or you find some other way to deal with it. And with this one, there is no other way to deal with it, right? If this had been x squared times x minus 3, no big deal. Just distribute the x squared in, then take the derivative. But there is no distributing into sine. Like, we're stuck here and we can't do this thing. The last thing I want to cover in this video is sort of the why, and I avoided it till the end because I wanted to make sure you were focused on the beginning part where I was covering mechanics. But I feel like this is kind of crazy. Like, sine x and cosine x have always been different things for us, and so for somebody to say, oh yeah, the derivative of sine, that's just cosine, it's like two worlds colliding, and it should be a little strange to you. There's a lot of reasons why this is. I could go through a formal proof, but I think the neater way to do this is for us to look at a graph. And if you're interested in seeing it on your own, pause the video for a minute. Think about what you learned in a previous lesson about the graphical interpretation of the derivative and apply that here. Think about the fact here that the black function is sine x and the red function is cosine. Think about what your knowledge of the derivative tells you about this. And if you don't want to do it on your own, I'm going to go through it right here. Right? Point by point, I want you to look at this and think about it. Right? Look at the graph of sine. If I pick this point right here, what's the slope of that tangent line? If you said, hey, it's about 1, how neat that the cosine function is 1 right there. Right? If I move further along, right, like this point right here, what is the slope of that tangent line? Well, would you look at that? That is a slope of 0. How convenient, the cosine just happens to have a value of 0 right there. And I can keep doing this everywhere, right? This point right here, the slope of that tangent line to sine is -1. Wow, how convenient for cosine to have a value of -1 right there. Even if I kind of picked something like a random weird point, like this guy right here, that's not a nice value, but look at what that slope is. That slope is barely negative. Sure enough, cosine is barely negative right there. If I came over here and sort of took this value here, that seems to be a fairly steep positive slope. Sure enough, cosine has a fairly positive value. We can see, and so this isn't really why, as much as we can see that the derivative of sine x is cosine x. You could do the same thing with showing that the derivative of cosine x is equal to negative sine x, but this video has already gone a little bit long, and you could do that on your own. If you want to, graph cosine, graph negative sine, and you will see this exact same business of derivatives and slopes and tangents matching up and being awesome. I hope that made sense. I'll see you in the next video.